Hello gentlemen, welcome to my channel. Today in this video we'll be speaking about the projectile motion. This kind of a motion of an object is just like a vehicle going through the curvilinear path in the road. Well, the difference in this is that the acceleration is constant, that is due to the gravity, and in the road the acceleration might change from place to place. And in this case, the projectile motion can be splitted into two components. One is the horizontal component along the base, and the other one the vertical component along the height or the y-axis. So we'll make a study of the projectile motion with the explanation in a graphical manner. So now we will derive the formula for the maximum height reached by the projectile and also the maximum distance traveled by the same in the horizontal direction. Okay, now we will study and derive the equation for the maximum height reached by the projectile and also the maximum distance in the horizontal direction that it will cover from the initial point of being projected. So let's first try to derive the equation for the maximum distance in the upward direction. We will follow the equation, that is h is equal to ut plus half at square. In this case, the acceleration is the acceleration due to gravity, and as we are going upwards, the acceleration will be in the opposite direction, so acceleration will be taken as negative, the negative g. So the total time up to the point O, the maximum height is equal the to the time reached for the upward direction velocity to be 0. So we'll put the formula, that is final velocity v is equal to u plus at, and in this case time to reach the maximum height O, the velocity would be 0. So we'll put the formula v is equal to u plus at. The acceleration here will be negative, so it will be negative g. 0 is equal to u sin theta minus gt. So u sin theta is equal to gt. T is equal to u sin theta by g. So this is the time taken for the projectile to reach the point O, and the total time for the object to fall right up to the same height where it meets the horizon at the point B is the double of this, 2 times of u sin theta by g. So for the S max, the maximum height, we will put the formula, that is ut plus half at square. U is u sin theta into the time is u sin theta by g minus half at square, because g in this case will be negative. Half g into t square. T is u sin theta by g. So square of that will be u square sin square theta by g square. So from this we get S max is equal to u square sin square theta by g minus half u square sin square theta by g, and that is equal to half u square sin square theta by g. So that is h max. That is the maximum height. So the h max, the total horizontal distance from A to B, is equal to the velocity into the time. Here in this horizontal direction, the acceleration is absent because the acceleration due to gravity acts only in the vertical direction. So the acceleration being absent, the h max will be equal to velocity into time. That is equal to velocity is u cos theta into the time. Time in this case is double the time that it took to reach the point up to the maximum height O. So the time will be equal to twice of u sin theta by g. So it will be equal to 2 into sin theta by g. That is equal to u square into 2 by g into sin theta cos theta. Sin of 2 theta is equal to 2 sin theta cos theta. So sin theta cos theta will be equal to sin of 2 theta by 2. So this we can replace here. That will be equal to u square into 2 by g into this value, sin of 2 theta upon 2, and that will be equal to u square by g. 2 get cancelled into sin of 2 theta. And if we want to calculate the value of theta for which the h max would be maximum, we have to find out the theta. H max should be equal to u square by g into sin of 2 theta. In this case, the sin of 2 theta should be maximum, and sin function is maximum when the theta is 90 degrees. That means 2 theta should be equal to 90 degrees, or in other words, theta would be equal to 90 degrees by 2, that is equal to 45 degrees. Okay, this is all about the derivation of the maximum height and the maximum distance for a projectile motion when an object is thrown in air with the velocity u. Okay, gentlemen, this is all about the projectile motion and the ways in which the maximum vertical distance and the maximum horizontal distance can be calculated. We have to keep in mind that for the upward direction, the acceleration should be taken negative. And one more thing is that while calculating the horizontal distance, the time should be taken double of the time that it takes for the vertical distance. I think you must have understood this theory, and it must have been an interesting one. So if you are new to my channel, please subscribe to it and do share this video among your friends so that they can also be benefited out of this. Do take good care of yourselves. See you soon in the next video. Till then, bye bye.